Hi girls, how are you? Just one more for you here for good luck. This is one of the trickier KC calculations where they're given KC and you're asked to work back and get the equilibrium concentration. Okay, so I'm going to do question 2014, question 9. All right, so again, I've written this out nice and simple for you just to see what you're given. You're given this equation and you're told that there's 2 moles of nitrogen monoxide at the start of the reaction. You're given the value for Kc, which is 20.25, and basically you're asked to calculate the equilibrium concentration of nitrogen. So we're looking for this value here, okay? So I've written out your equation, what you're looking for, and then we're going to fill in our table the normal way that we do. All right, so here's one I prepared earlier. Here's the table. This is our equation again. This is my Kc just written in the corner just to remind me when I get my table done. And I've written in the information that I'm given in the question, which isn't very much to be honest, which is that there's 2 moles of nitrogen monoxide at the start. Okay, so again, we're going to use X to help us with this. We're going to look at our equation here, and you can see that it says for every 2 moles of nitrogen monoxide used, I'm going to produce 1 mole of nitrogen and 1 mole of oxygen. So the moles at equilibrium of nitrogen and oxygen are going to be X and X. And the amount of nitrogen monoxide that's used up is going to be 2X. Is that okay? See what I've done? So I've used X there to represent a number I don't know, and I've used 2X here to represent another number I don't know. The amount of nitrogen monoxide twice as much because of the molar ratio there, okay? Which means that the amount of moles of nitrogen monoxide at equilibrium will be the amount that's there at the start minus the amount that gets used, which is 2 minus 2X, like that. Is that okay? Now in this question, there's no mention of any volume. It doesn't say in a 10 litre flask or a 5 litre flask or anything like that. So we can assume that it's in a 1 litre flask, and we basically don't have to make any allowances for the concentration here, which makes our actual equation actually a little bit easier than the last one that that I just did, that hopefully you've looked at by now. But basically now I'm in a position to plonk my numbers into my equation here and solve for X, okay, which is what I'm going to do. So my concentration of N2 is X. That's going to be multiplied by the concentration of oxygen, which is X, so that's X squared. And I'm going to divide that by the concentration of nitrogen monoxide at equilibrium, which is 2 minus 2X. And don't forget to square that, because remember, it's Kc raised to the power of 2, isn't it? So it's 2 minus 2X squared, and that whole equation is equal to 20.25, like that. Is that okay? So again, from now on, it's just easy peasy maths. Well, we'll see if it's easy peasy or not. What I've done it again on paper, if you don't mind, just to take, it's a lot of steps, and I end up going through about 15 million whiteboards. So I'm going to do this a little bit on paper, and I'm going to show you how it's done now. Okay. So again, I'm rewriting my equation here. Here we go. Have a look. So there you have it. So that's rewritten exactly as it was. X squared over 2 minus 2X squared equals 20.25. So to simplify, which is really all I'm doing here, I'm going to multiply out the bottom, 2 minus 2X multiplied by 2 minus 2X. You should be able to do that. And you get 4 minus 4X plus 4X squared equals 20.25. And again, I don't really like fractions. Sure, I don't when I'm trying to solve for X. So I'm going to bring this over here like that and multiply this bottom side, there it is, by 20.25. It's divided on that side, so I'm going to multiply it on this side. So now I'm going to multiply out this side here, multiply 20.25 by 4 by minus 4X plus 4X squared, like that. When I do that, I get X squared, remember that X squared hasn't moved, is equal to 81 minus 162X plus 81X squared. So I'm nearly there. I'm just going to get rid of that X squared now by bringing everything over to the one side. 81X squared minus X squared. Okay, so I brought that over. Minus 162X plus 81 equals 0, which gives me 80X squared minus 162X plus 81. And you can see what the story is now. I'm ready to use my formula, minus B plus or minus the square root of B squared minus 4AC over 2A, which again, if you're not sure of, is in your tables book. So I plugged in my numbers. This is minus B is going to be 162 plus or minus the square of 162 squared minus 4 times 80 times 81. That's B and C, isn't it? Divided by 2A. There you go, like that. Okay, 2 times 80. Right, multiply it out. Or sorry, well, I multiplied this bit out and this bit, and we get, that's still 162. The square root of 26,244 minus 25,920. Subtract these, and you get the square root of 324. Okay, I still haven't done anything with this or this. Square root of 324 into your calculator is 18. Okay, can you see that there? I'm running out of space here. Sorry, I'm going to just push this up a little bit. So it's 18. Okay, So I've got 162 plus or minus 18 over 160. Now, remember what we said. There are two options here, pluses and minuses. So I'm going to go with this one first. I'm going to add 18. So 162 plus 18 gives me 180 divided by 160. And that gives me 1.125, right? Now, 1.125 is too big. It can't be acceptable. Why is it too big? Because look back at my table. The amount of NO2 that's used is 2 times X. But I only started with 2 moles of NO2. Can you see that? So 2 times 1.25 is obviously bigger than 2, isn't it? So that value cannot be right. All right? So I know that that's wrong. It's too big. I can't possibly have used 2.25 moles of NO2 when I only started with 2 moles. So I now know that the correct value must be 162 minus 18 over 160, which is 144 over 160, and that gives me 0.9 moles. And that's much more believable, okay? Because 0.9 times 2 is 1.8, and that's acceptable. 2 minus 1.8 allows me to work out the amount of nitrogen monoxide at equilibrium then. All right, so the amount of nitrogen at equilibrium, which is what the question actually asked for, is 0.9 moles. The value of X is 0.9. The value of my N2 in my equation, which is there, can you see that, is 0.9. All right, so there's a couple of examples of those kind of questions now, girls. I hope that makes life a little bit easier, and you should be able to tackle those more difficult KC questions now. Any trouble, let me know. If there's particular examples you're stumbling across that you're not sure how to do, I'll try and do one for you. Let me know how you're getting on, and best of luck with it, all right?